I'm Saurabh Shikdar from ICF. I've been working at ICF for more than 2 years now, and primarily I'm working on California's statewide gas emerging technologies program. First of all, thank you for joining in. Today, I'm going to present on one completed GET project titled Boiler Related EE Measure Assessment. So let's proceed. Here is the agenda for today's outreach session. First, we'll go through project background and assessment objectives. Then we'll discuss the findings from literature review and historical IOU participation data analysis. We'll also talk about the customer survey methodology that we adopted and findings from customer and manufacturer interviews. Lastly, we'll go through the conclusions and future recommendations. I would like to let everyone know that we'll have question answer session at the very end of the session. So I'll go through my slide deck first and then uh, answer if you have any questions. So let's move on. This project reviewed the currently implemented energy saving measures and emerging technologies related to use of natural gas boilers in the California IOU territory. The goals of this ET study were to perform literature to perform literature research to identify existing data for California IOU boiler counts. Also, the other major goal was to estimate measure uptake levels from CIDR's data and conduct customer surveys to understand customers' input on installed measures as well as particularly add-on measures. We conducted several manufacturer interviews to understand more about emerging technologies and boiler accessories. So this was about the goals of this ET study. This slide summarizes the project findings. We interviewed about 25 boiler manufacturers and distributors and derived or identified 11 add-on related measures from those discussions. Also, we identified about 10 measures from literature review as well as US Department of Energy tip sheets. The estimated efficiency increase ranges for for all the identified measures and technologies from 1% to 8%. As far as the barriers in measure implementation are concerned, we identified that some of the barriers were space constraint, variability in sizes of boilers, as well as high upfront cost. During the course of project or different milestones, we segregated the identified measures into three categories. Those were near-term hits for the program, second, suitable for field or lab testing, and the list of non-viable measures. Boiler systems are used to produce steam and or hot water, which is used for several primary purposes, such as space heating, domestic hot water usage, and pool heating. The boilers are further categorized into industrial, commercial, and multifamily types. This project focuses primarily on boiler add-ons and not the entire boiler outfit. The objective was to learn more about emerging technologies in that segment and their impact on boiler system efficiency improvement. So let's proceed to the next section, which is literature review. This slide summarizes the boiler inventory characterization in US. And as you can see in the first pie chart, the natural gas boilers are uh, lower capacity boilers compared to other fuel types. And you can see the segregation with respect to different fuel types as well as their installed capacities. This is for the entire US. And also you can see the categorization of boiler counts in the state. And for estimating that inventory, we leveraged multiple data sets. The first one being publicly available boiler licensing data, which was shared by air quality management districts in California. And this is compiled from the data shared by about 10 AQMDs in the state. The second source for estimating boiler counts was Cadmus multifamily study, which was conducted in 2019. So you can see the numbers and their categorization with respect to different sectors such as multifamily, industrial, and commercial. These are the findings from Cadmus multifamily study. One of the important findings or their conclusion was the end usage, which is most often served, is domestic hot water heating, and the pool heating is the next prevalent use. As far as the utilities are concerned, SoCalGas territory has the highest number of multifamily boilers among the three major utilities in California. During the literature review milestone, we also reviewed the boiler studies or previous studies completed in other states, such as Oregon and Minnesota. And this slide summarizes the findings from those studies. Oregon study highlighted that focusing on improving the design and performance of condensing boilers is important. Also, the other study, the other field study indicated that on-field operation had better than expected space heating performance for condensing boilers. Let's move on to the next step where we reviewed the US Department of Energy tip sheets. USDOE has published several tip sheets, particularly for boiler accessories, and we reviewed and understood some fundamentals of that and correlation between different parameters and their impact on efficiency improvement as well as fuel savings. So these are some of the snapshots pulled out from those tip sheets. Also, as you can see, those indicated some rules of thumb in industry, which is helpful in estimating percentage fuel savings or percentage efficiency improvement. These are tip sheets related to burner upgrades as well as energy recovery potential of economizer. The next milestone or the next section is historical IOU participation data analysis and customer surveys. California Energy Data and Reporting System, which is CEDARS, manages California EE program data reported to Commission by IOUs and RENs. We analyzed these claims submitted during the period of last 5 years, starting 2018. As you can see in the table, we did some year-on-year comparison on measure level, which helped us to determine which boiler EE measures are implemented more compared to others. We identified that more than 90% of the claims submitted during 2019 to 2021 were for deemed measures. We also categorize the claims in different sectors, such as commercial, residential, ag, and industrial. And we saw that there were significant number of claims submitted under commercial and residential category or sector compared to agriculture and industrial. Some custom category claims were also identified or included, which were VFDs on combustion fans, stack economizers, system insulation, etc. But this highlighted the significant opportunity for measure package development related to boiler add-ons. As I said before, customer survey was an important element of this study, and we reach out to about 4,400 contacts, customer contacts received from AQMDs, as well as confidential data requests from SoCalGas. These are the two major AQMDs, Bay Area and South Coast. So you can see that in terms of number of contacts. The objective of conducting customer surveys was to collect more information about their installed boilers and implemented EE measures. The survey data collected information about boiler data, their primary end usage, prior participation data, and measures installed. Also, we tried to ask more information about customer pain points, if any. So these are some of the plots from customer survey data analysis. Overall, we had about 46 responses on our online survey, and our primary mechanism of outreach was email. As you can see in the first plot, we can see the primary end usage is domestic hot water heating, and the next one is space heating. We also found that this is in line with the Cadmus multifamily study findings, which was completed in 2019. The second plot indicates that more than 40% of the boilers are fire tube boilers for the responses that we had received. We also tried to understand which accessories or which technologies have been installed more compared to others and which are prevalent add-on measures. And we identified that advanced burner technologies, flue gas, recirculation, as well as VFDs on combustion fans, those are uh, some of the measure categories or accessories that customers have installed. So we discussed about customer surveys, sitters participation, data analysis, and some of the findings from that. We also went through findings or remarks from U.S. Department of Energy tip sheets. Now let's move on to the next section. In this section, we'll talk about manufacturer interview findings and summary of emerging technologies. In the subsequent discussion, we have anonymized the names of manufacturers in this presentation as well as the project report. There were several there were several technologies that we tried to go through and evaluate. But if you have any detailed question about specific one, feel free to ask here or maybe reach out to me later. So this is the first manufacturer. After Before that, after completion of customer surveys, we interviewed about 25 boiler manufacturers and distributors. As I said before, the objective was to understand more about emerging tech and boiler add-ons. This one is the first manufacturer A, and its products pertaining to flash steam recovery. The flash steam is generated when high pressure condensate is discharged to lower pressure, and its product exhaust vent condenser increases the feed water temperature by promoting condensation of flash steam. For every product that we surveyed or we interviewed, we tried to uh, gain insights or information about estimate efficiency, increase of boiler system, and exhaust vent condenser typically increases the efficiency of boiler system by 1%. Boiler blowdown is carried out to control the amount of TDS in the boiler, and the discharged water is hot, dirty, as well as pressurized. This generates a lot of flash steam when released at atmospheric pressure, which provides the opportunity of heat recovery. So the second half of the slide talks about or discusses incorporation of flash vessel, which is used to recover energy from flash steam, and it facilitates separation of hot water and flash steam. The flash steam directly goes to the deaerator and a heat exchanger increases the temperature of boiler feed water using that hot water. Cold water break tank is useful for application where there is no simultaneous flow of boiler blowdown and makeup water. This particular product or system or this particular product or technology is estimated to increase the boiler efficiency by 1.7%. This slide is about flash recovery energy management equipment system. It is another heat recovery system to recover waste heat from condensate return and used to preheat the boiler feed water. There are two passes. In one pass, heat from flash steam is recovered, and in second pass, heat from condensate water is recovered. For every 6 Fahrenheit increase in temperature, 1% fuel savings are estimated to achieve from installing this particular equipment. And overall, this would increase, this is expected to increase the boiler system efficiency by 5.5%. The manufacturer told us that typical applications of these systems or equipments are in hospitals and pharmaceutical industries. The next segment is boiler economizers and their alternative configurations. The objective of installing a stack economizer is mainly to increase the temperature of boiler feed water using heat content of flue gas. This is another technology or product by manufacturer A that we had gone through in the previous slide. It's two element water controller, which ensures that water level is made to rise at peak loads or higher steaming rates, and water level in the boiler stays constant at all the loads. So this would ensure that feed water enters the economizer at peak loads when the heat content of flue gas is on the higher side. Basically, it's additional controller for integrating steam flow meter signal and water level indicator signal. This this is estimated to increase the overall boiler efficiency by 1 or 2%. These are different types of multi-stage condensing economizers, which can be paired with non-condensing hot water boilers. Also, these are available in different configurations such as two-stage stack or side-by-side design, and combination of multiple small boilers, multiple small boilers can be combined to one particular heat recovery unit. Some of them are some of them are roof hanging units, which provide or facilitate ease of installation. The efficiency gains varies with different products that are available at manufacturer's end, and it varies from 5 to 12%. We also went through and understood the fundamentals of TMC technology, which is incorporation of ceramic tube bundles in boiler exhaust, which recovers both sensible and latent heat component. This particular technology works well for smaller size boilers up to maximum size of 300 HP. And one of the major barriers in implementation is high installation cost, and the heat transfer effectiveness decreases for larger boiler tubes. The second half of the slide is on-demand condensing economizer, which is suitable for sites having space constraints, and this heat recovery unit can be installed at, say, 100-foot distance from boiler and can be invisible to boiler system. The operation, the unit is the operation of unit would take place when hot water is needed and heat is available. For this one as well, multiple boilers can be teed up to one on-demand economizer system. So that's another advantage. But there's addition of control system as well as fan to avoid any back pressure and condensation concerns. The manufacturer indicated that typical payback for this system is 1 to 2 years. The on-demand economizer one. This slide talks about glycol scavenging system, which is basically combustion preheating using glycol as a heating medium. The heat transfer takes place from flue gas to glycol and from glycol to combustion air. This improves efficiency of boiler system by 2 to 3%, but air preheating hurts NOx. Also, there are major upgrades required in fan and burners in order to have this particular system at the facility. And this can be installed for boiler systems of size larger than 200 HP. The second one is parallel positioning, which optimizes the fuel air ratio by using high resolution actuators for both fuel and air. This is estimated to increase the overall efficiency by 2 to 3%. In the same category, oxygen trim, which maintains the percentage of excess air by continual measurement of outside air temperature, humidity, and normal wear and tear. This is also estimated to increase the efficiency by 2 to 3%. In our initial survey or customer survey, we saw that burner related upgrades were one of the major categories as far as the implementation is concerned. This slide also has FGR, which is flue gas recirculation. Again, it's an effective way of reducing NOx, but it has negative or no major impact on increase in boiler efficiency percentage. The last equipment or technology is related to dual returns for hydronic systems with different loops. Dual returns overcome the limitations of traditional condensing boilers with single returns. As you can see in the figure, the higher temperature return is to the upper inlet section of heat exchanger and lower temperature return to lower inlet section. This increases the condensing zone, which enhances the boiler efficiency. These systems are designed to support systems with diverse load demands such as space heating, domestic hot water heating, and pool heating. The second plot highlights the impact of return water temperature on boiler efficiencies. Overall, this differs with respect to applications and installed systems, but it is the manufacturer indicated that this particular system is expected to increase the overall efficiency by 3 to 5.5%. So we talked about different products, equipment, and systems or technologies in the boiler accessories segment. This is the summary of different measures and the efficiency levels. I tried to share the levels in terms of ranges or tentative figures which were shared to us in those interviews or discussion. But please note that those efficiencies are not additive, particularly if there is a technology overlap. So let's proceed to the last section, which is results and recommendations. So we saw and we discussed about the estimated boiler count in the state. In the first project milestone, we tried to estimate the boiler count and state and its categorization with respect to different sectors such as multifamily, industrial, and commercial. We leveraged different data sources in order to complete that step. The historical IOU participation data analysis indicated that more than 90% of the claims submitted were for deemed measures. We also discussed the customer survey results and the measures that were found to be prevalent from the 46 responses that we received. Other major component of the study was boiler manufacturer and distributor interviews, and we discussed different technologies or products and its impact on overall efficiency of boiler systems. From customer surveys, site surveys, and manufacturer interviews, we try to understand the potential barriers in implementing measures related to boiler add-ons, and we try to understand why some measures are implemented more compared to others. And some of the measure barriers that we identified were space constraint, variability in size, and high upfront cost. So this is the last slide or conclusion slide on different technologies or products related to boiler add-ons. We tried to put them in 3 baskets. The first one being good candidates for near-term hits for the program, and the second one being which requires additional testing, field testing part. The third category is the list of technologies which are not viable for further development. Some of the reasons for including those measures there were impact on NOx as well as impact on EE. So as we discussed, one measure had positive impact on NOx reduction, but no impact on EE. So those are included there. Some measures may be particular or particular to a particular system or application and might require additional analysis in terms of field testing or lab testing. So we have included those technologies or measures in the second category. The metrics that we used for putting different technologies or products into 3 baskets were ease of installation, energy saving potential, installation limitations, measure cost, etc. So thank you all for joining this session and hope this was useful for your study or product evaluation. And before we move on to Q&A segment, here is a brief note about the upcoming outreach event. The next one is on another completed GET project, which is ultra low NOx burners. It is scheduled on November 7th. And a separate invitation will be sent out soon. This is the last slide of our presentation. Please contact Brian, our program manager, if you have any questions about the GET program in general. Feel free to reach out to me on LinkedIn if you have specific questions about information that I shared or discussed with you, apart from Q&A that we have. Also, feel free to reach out to us on our GET LinkedIn page for your feedback on presentation, as well as if you want to share any ideas related to program. Thank you so much. Any questions for me? Did you find it useful?
Hello. Can you hear me? This is Adam.
Yes. Hi, Adam.
Hi. Yeah, thank you for the presentation. That was fantastic. Job well done. And it's great to see get updates on what's going on here in California. I'm also in California. But I was curious if you guys what your collaboration is with the Gas Technology Institute, if you guys work directly with them and at what capacity, if so. And the only reason I ask is because there might be some areas of overlap, and I was just curious if that's a group that you coordinate with for your emerging technology work on the gas side.
You want me to try to answer that one?
Yeah, sure.
Yeah, so we work and coordinate with GTI. It's not, we're not necessarily doing their projects or vice versa, although we have one we're working on them with. But yeah, we do coordinate with them.
Okay, no, that's great. I the reason why I ask is, like I said, we on the Energy Star side for commercial food service, we work a good amount with them, and I was just curious if that was, especially with NOx emission testing and whatnot. I know that's something that's near and dear to their hearts, and I was just curious. But thank you. Yeah.
Yeah, and thank you, Adam, for your feedback. And in my discussion with boiler manufacturers or the technologies that we discussed a while ago, yeah, some of the manufacturers indicated that they are working with GTI as well, or they had previous or past collaboration with GTI.
Fantastic. Thank you. And thank you again for the presentation. That was really, really informative.
Thank you.
I don't see any other questions in chat either, Saurabh, so that might be it.
Yeah, I was checking Teams chat as well. And thank you for confirming, Alfredo.
Oh, a question just came in. If there will be a formal study published with this information.
Yeah, we have. Do you want to take this question, Stephen? If in terms of sharing the project report or slide deck.
Yeah, I'm just maybe generally. So all the ones I believe we're presenting in these sessions have completed reports. You can either go to our webpage, I guess we could provide that, or the statewide webpage, and I believe that's also the statewide emerging technologies webpage, or I believe it's all being copied over to the legacy ETCC website as well. So there's like 3 places you can get links to this and the other studies.
Yeah, once again, thank you everyone for attending this session. And yeah, thank you, Stephen, for sharing the link of our webpage.
Yeah, that's actually the statewide one, which contains not only the gas work that we're doing, but the electric emerging technologies as well through CalNext.
I don't see any other questions, Saurabh. I think that might be it.
Yeah, I think that's it. And once again, thank you so much for attending this session and have a great rest of your week. Take care.
Thank
Thank
you,
you.
Saurabh, and thank you,
Saurabh.
rest of us for attending.
Thanks, everybody.
Thank you. Bye-bye.
Bye.